In this demonstration, we're going to examine isolation levels and locking. Isolation levels are important to understand because they have significant impact on both data consistency and potentially the performance of the server. So to check the current setting of the server at the global level, we can execute the show command, global variables. We're going to use the like keyword and then two wildcards. The % says to match any string that contains the word isolation. It may start with 0 or more other characters, and it may end with 0 or more other characters. So show us the global variable that contains the word isolation. And so in the result, we see that the current isolation level is set to repeatable read. And we can change that setting by using the set command. We're going to say set global transaction isolation level and then which level we want to set it to. In this case, we're going to set it to read uncommitted. And now we can check and see that we've changed the global value at the server level. We've changed the value to read uncommitted. And likewise for repeatable read and serialization. So what does read uncommitted mean? If we have two transactions, transaction A and transaction B, if transaction A is reading, selecting from a table, while transaction B is changing data in that table, the same data that transaction A is reading, transaction A will read the data changed by transaction B even though transaction B has not completed. It has not committed the data. Transaction A will still read that data. Now, read uncommitted can cause data consistency issues. However, it allows the highest level of concurrency in the server. That is, many transactions can be reading from tables simultaneously without the risk of being blocked by a lock caused by a transaction writing to the table. Read committed, on the other hand, is restrictive. It will not return data that has been changed by another transaction until that data change has been committed. Repeatable read will return the data that was read regardless of whether or not that data was changed by another transaction. So for example, I have transaction A that does a select on a row in a table. Transaction B makes a change to that row that transaction A just read. Transaction A does some other work, then reads that same row again. In the meantime, transaction B has made a change to that row. Transaction A will get the same data it read with the first select statement, regardless of whether or not transaction B has committed its update command. Serializable, on the other hand, is the most restrictive isolation level. If transaction A is reading and writing two rows in a table, all of those rows, both those being read and those being written, will be locked so that no other transaction can access those rows. Two side effects of serializable: many locks, both read and write rows get locked, and transactions that are just reading data that is also being read by transaction A are blocked. They cannot read that data. Even though it's not being changed, they cannot read it until transaction A commits and releases its locks. Using the serializable isolation level has the potential of causing serious performance issues on the server because of the decrease in concurrency and the increase in lock management. So let's see how all of this plays out with some queries. I've created two connections. I have my local course connection and I have my local root connection. We're going to use the same data we used in the previous demonstration, the Sequela film table, and we're going to be looking at film ID 52. The current value of film ID 52 has 3 L's in the misspelling of ballroom. So we're going to go to local course connection and confirm that we're looking at the same data, 3 L's in the misspelling of ballroom. Now, let's change the isolation level in this session for this connection only. This has no effect on the global server setting. So for the life of this connection, we're going to change the isolation level to read uncommitted. Currently, the isolation level is read uncommitted. So we're satisfied that we're going to be reading uncommitted data. And now we're going to update the film table for film ID 52, and we're going to update it with ballroom mockingbird, with ballroom misspelled this time with 3 A's instead of 3 L's. And we're going to do this within a transaction. We are not going to commit the transaction, so the transaction will be open uncommitted when we run this code. So let's run it. So now there is dirty data. There is an uncommitted update of the film table for the row film ID equals 52 that changes the title from BALLL room to BAAALL room. So what are we going to see when we go to our other connection and read this data? Well, let's make sure that this connection is set for the proper isolation level. See, now in this connection, our isolation level is set for repeatable read. It will not read that uncommitted data. So we're going to change the isolation level to read uncommitted. And let's double check and make sure that that happened, and it did. When we read the film table with row ID 52, the original value was BALLL room. The changed value, BAAALL room, has not yet been committed by transaction A. So when we run our select statement, we see the uncommitted value from transaction A because our isolation level is set to read uncommitted. So in many applications where data inconsistency is not an issue, performance can be greatly improved on the server by setting the isolation level to read uncommitted. But again, be careful because this means that you're going to see data that will potentially be rolled back by the transaction that's updating that data, and you've read it before the commit on that transaction. Again, this is application dependent. In some cases, this works very, very well to satisfy the requirements of the application and provides a level of performance that cannot be matched by the other isolation levels. If we change our session isolation level to read committed, let's confirm that we did read committed. Now our transaction in our other connection that's updating the title to BAAA room has not committed. So the data is not changed in the database until the commit command is executed. So now we're saying from this transaction, read only the committed data. What's the committed data? Well, it is the data as it existed before this transaction executed. So what we should see here is the original value of the title, which is 3 L's, LLL. So that's read committed, which only returns data whose changes have been committed to the database. So now if we run the commit command in our local course connection, we have actually changed the data. And if we go back to our local root connection, where we previously had just read the 3L version of the title, now that the local course connection has committed its update, we should see the 3A version of the title. And so if we run our select statement again, we can confirm that indeed now we are reading the value that was committed by the local course connection. So in review, uncommitted and committed transaction isolation levels have significant differences in the way that data inconsistency is treated. Serializable is the most restrictive isolation level and will impact performance by increasing the number of locks and reducing concurrency. And repeatable read guarantees that if within a transaction data is read twice and somewhere in the middle of the two reads, another transaction changes that data, the second read will return the same data as the first read, regardless of the committed or uncommitted changes made by the other transaction.